We're going to consider this question which says a truck and trailer with mass 4.5 times 10 to the power 5 kg approaches the police barrier with the velocity of 7.5 meters per second. The brakes then fail and hits the barrier and comes to rest in a distance of 6 meters. A. Calculate the time of impact on the barrier, and B. Calculate the impulse on the truck. So this is the question that we're going to answer in this video. Without even wasting time, we are going to come up with the data that we have. So we have the mass of the truck and trailer, which is 4.5 times 10 to the power 5 kg. What else do we have? We have the initial velocity, meters per second. When it comes to rest, the final velocity will be equal to 0. Then we have the stopping distance, which is x 6 meters. So the information that we have is sufficient enough to find what we are required to find. Here we are trying to find the time of impact on the barrier. So we can say solutions. Part A. In order for us to find, we have this object that is moving with a certain velocity and it has mass, so there is an aspect of momentum. And since we want to find the time of impact, we are going to use the concept of impulse. So here we're going to use the concept of impulse. We have impulse is Ft, then momentum is equal to mv. Now, since we want to find the value of t, we can divide by f, even here by f, so that this and this will go. And what we're going to have is here we have t is equal to mv over f. But we know that f is equal to ma. F is equal to ma. So if we replace f by this, we are going to have mv over ma. And this can even cancel, and what we're going to have is v over a. Now, from the information that we have, we can find the value of a, since we have u and we have v. Here we have on the equations of motion, the most suitable equation that we can use is v squared is equal to u squared plus 2ax. And we know that this is 7.5 squared, which is equal to 0 squared plus 2a times 6. So this is going to give us 7.5 squared is equal to, this one we're going to have 2 times 6, we're going to have 12a. We divide it through by 12, even here by 12. And what we're going to have here is a is equal to, when we punch on a calculator, what we're going to have is 4.675, which can be rounded off to 4.7 meters per second squared. So now, putting this in this, we are going to have t is equal to 7.5 over this one. We are going to have, we have 4.7, and this one will give us 1.595, and this one can also be given as 1.6 seconds as the time of impact, on the barrier. And for the second part, which is B, finding the impulse. This is simply Ft. It is Ft, and it is given by, so F is equal to ma, force is equal to ma, then times time. The m that we have is 4.5 times 10 to the power 5 times a. The acceleration that we found was 4.7 times 1.6. So punching this on a calculator, we are going to have 338 400 Newton second, which can be given also as, so here we have 1, 2, 3, 4, 5. When we express it into the standard notation, we're going to have 3 point. So this one will become 4 times 10 to the power. So this is 3 to the power 5 Newton second.